In this video, we will be looking at section 6.5, which covers modeling with trigonometric equations. We're going to start by solving triangles. So solve the following triangles for the unknown sides and angles. You should note that when we're measuring triangles, we pretty much always use degrees, so I'm going to make sure that I am in degree mode. So in this first one, it looks like I need to solve for side C, because it's a right triangle, that's my hypotenuse. So I can do 3 squared plus 7 squared equals C squared. So 9 plus 49 is equal to C squared. That's 58 for C squared. So C is the square root of 58, which is about equal to 7.6158. So that solves for side C. Now we need angle A and angle B. So if we start with angle A, the opposite is 3, the adjacent is 7. So I could say the tangent of angle A is equal to 3/7. And that would mean A is equal to the inverse tangent of 3/7, which is 23.20 degrees. And then for angle B, the opposite is 7, the adjacent is 3. So I could say the tangent of angle B is equal to 7/3. So B will be the inverse tangent of 7/3, which is 66.80 degrees. You might be asking yourself, well, why did she use tangent if she knows C? Because 3 and 7 are easier to work with. Once you had A, why didn't you recognize that this is a 90-degree angle, so B had to be 90 minus what A is? I could have, you're right. There are a bunch of ways to solve these. Just use whatever method comes to mind. Looking over here at my second triangle, I need to find side A, and then angle A and angle B. So let's start with side A. Using the Pythagorean theorem, I'll have a squared plus 10 squared equals 12 squared. So that'll be a squared plus 100 equals 144. A squared equals 44, so a is the square root of 44. I could reduce it to 2 times the square root of 11, but that is about equal to 6.6332. All right, now that I have side A, I can find my other angles. So let's start with angle A. I know the adjacent is 10 and the hypotenuse is 12, so that'd be cosine of angle A is equal to the adjacent 10 over the hypotenuse 12. If I inverse cosine that, the inverse cosine of 10 over 12 is about 33.56 degrees. And then for angle B, the opposite is 10, the hypotenuse is 12, so I could use sine of angle B is equal to 10 over 12. And if I inverse sine that, we get that angle B is about equal to 56.44 degrees. Hopefully those aren't too bad, using the Pythagorean theorem along with our definitions of our other trig functions. Next up, these are some of my favorite. I don't know why, I really enjoy them. We're going to find a possible formula for the trigonometric function whose values are shown in the tables. So first up, we have our x going 0, 1, 2, 3, 4, 5, 6. Our y goes -2, +4, +10, +4, -2, +4, +10. So you can kind of see that it goes up to 10, back down to -2, up to 10. So you get that sinusoidal feel. Let's start by finding our midline. Our midline is the midpoint between the low and the high. So if we average our low and our high, we should get our midpoint. For the midline, I can take -2 plus 10 divided by 2. That's 8/2, which is 4. Hey, how convenient. It looks like 4 was our middle point anyway. So we have our midline. We can find our amplitude because the amplitude is the distance from the midline to the highest. So from 4 to 10, that's going to be 6. The period is how frequently we repeat, and we go -2, 4, 10, -2, 4, 10. So it starts here and here. Those are 4 apart, so our period is 4. We know that our period P equals 2 pi over B. So 4 is equal to 2 pi over B, multiply by B, divide by 4. We get B is equal to 2 pi over 4, which reduces to pi over 2. We are starting at the lowest part of our graph. We're starting at the bottom. That means we're looking at a negative cosine graph. And that is when x equals 0, so we don't have any horizontal shifting going on. This can be represented by y equals -6 times the cosine of pi over 2 x plus 4. Let's try the next one. It looks like we're starting at 1, going to -3, -7, -3, +1, -3, -7. So it looks like we're starting at the high point this time. For our midline, we can average our highest and lowest. So 1 plus a -7/2, -6/2 is -3. Bet you couldn't have guessed that from the table. So our midline's at -3. The distance from our midline to the highest point, -3 to 1, is going to be 4 for our amplitude. Our period is how frequently we repeat. 1, -3, 7, 1, -3, 7. It looks like it happens here and here. Those are 4 apart like last time. So our period is 4. I do the same math, so I'm just going to kind of cheat and use what I had before. That tells us B is equal to pi over 2. What's different is this time we're starting at the highest point. If we're starting at the highest point when x equals 0, that's a regular cosine graph. So this will be y equals to a +4 times the cosine of pi over 2x plus our midline of -3. So I'll put a -3 out back. Next up, we're going to talk about oscillating temperatures. So outside temperature over the course of a day can be modeled as a sinusoidal function. Suppose you know the high temperature for the day is 63 degrees and the low temperature of 37 degrees occurs at 5 a.m. Assuming T is the number of hours since midnight, find an equation for the temperature D in terms of T. All right, sounds like there's a lot going on there. We know our low and our high points, so that means we can find our midline and our amplitude. So for the midline, we average the top and bottom temperatures. So that's going to be 63 and 37. So 63 plus 37 divided by 2, that's 50. So that's going to be my midline. My amplitude is the distance from the midline to the highest. If the highest is 63 and my midline is 50, that means my amplitude is 13. We're saying that the temperature over the course of a day can be modeled as a sinusoidal function. So we're going to take our period to be a full day. We're measuring T in hours, so that'll be 24. So I need to find my B value. Our period 24 is equal to 2 pi over B. Multiplying by B and dividing by 24, we get B equals 2 pi over 24, which reduces to pi over 12. The only point we know when it happens is that the low temperature occurs at 5 a.m. So if we shift our starting point to be at 5 a.m., meaning we have a horizontal shift to the right of 5 hours, then we can think of this as a negative cosine graph because we're starting at the bottom. So we would have a function, the temperature in degrees as a function of time t is equal to, it's a negative cosine graph, so negative amplitude of 13 times the cosine of our b value, pi over 12, times, we were using t as our variable, we need to move to the right 5, so that'd be minus 5, and then we add our midline on the end, plus 50. So you can now plug in any value of t being a number of hours since midnight, and that will tell you the temperature at any given time. Second, outside temperature over the course of a day can be modeled as a sinusoidal function. Hey, it's almost like we just said that. Suppose you know the temperature varies between 47 and 63 degrees during the day, and the average daily temperature first occurs at 10 a.m. How many hours after midnight does the temperature first reach 51 degrees? All right, let's see if we can come up with an equation for this. So I'm going to start it kind of like we did the last one by finding my midline and my amplitude and stuff. So our midline, I can average the high and low temperatures, which is 47 and 63. 47 plus 63 divided by 2, I believe, is 55. Our amplitude is the distance from the midline to the highest. So from 55 to 63, that's an amplitude of 8. Just like last time, we're dealing with a period of 24 hours. So we will say that our period is 24. And since we already did the math for that, I'm going to use the fact that b equals pi over 12. This time, we know that the average temperature, which was 55, first occurs at 10 a.m. So if we shift our quote-unquote starting point to the right by 10, then we know we are at our midline. I'm going to assume because it's 10 a.m. that it's warming up. That might be a bit of a stretch to assume, but usually it warms up in the morning, at least in the late morning. So if we're at our midline increasing, then this is a regular sine function. So if I come up with a formula, I'm looking at the temperature in degrees as a function of time is equal to an amplitude of 8 times the sine of pi over 12 times t minus 10 for our horizontal shift, plus our midline of 55. We are being asked how many hours after midnight does the temperature first reach 51 degrees? So I want the temperature to be 51 degrees. So let's see if we can solve that. So I'm going to plug in 51 for d of t. d of 51 is equal to 8 times the sine of pi over 12 times t minus 10 plus 55. I'm trying to solve for t. So I can subtract my 55. That'll give me negative 4 is equal to 8 times the sine of pi over 12 times t minus 10. Dividing by 8, I get negative 1/2 is equal to the sine of pi over 12 times t minus 10. So we have this sine of some angle is equal to negative 1/2. I'm going to take the inverse sine of both sides. And because I see pi over 12, I'm going to think in radians. I could type this in the calculator, it'd get me to the same place, but to save time, -1/2 is one of the values on my unit circle. To have a sine value of -1/2, that's going to be right here at 7 pi over 6, as well as over here at 11 pi over 6. So we get 7 pi over 6 and 11 pi over 6. Those are the two solutions between 0 and 2 pi. And I did this by taking the inverse sine of both sides. So this is equal to my pi over 12 times t minus 10. Like we did in the past, we need to add 2 pi k. You'll see why in the end, because it's actually really important this time. Oops, and I did not leave space on this one. 11 pi over 6 plus 2 pi k. I need to solve for t still, so I'm going to multiply both sides by 12 and divide by pi. What that amounts to is multiplying both sides by 12 over pi. In my first term, the pi's cancel out, and I'm left with 14. That's actually a pretty nice number. Plus, the pi's cancel out, and 2 times 12 is 24k, is equal to t minus 10. If I add the 10 over, I get 24 plus 24k is equal to t. Going back over here, I'm going to do the same thing. I'm going to multiply both sides by 12 over pi. In the first fraction, the pi's cancel. I'm left with 22 plus 2 pi times 12 over pi is 24. And then we still have our k is equal to t minus 10. If I add the 10 over, we get 32 plus 24k is equal to t. We were trying to figure out what time we hit this temperature. So it looks like we hit that at when t equals 24 and when t equals 32. But k can be any integer in our world. We want to get as close to midnight as we can, and t is the number of hours after midnight. If I let k equal -1, and we get 24 plus 24 times -1, that's 0. If I do it here, if k equals -1, 32 plus 24 times -1, we get 8. So this temperature happens 0 hours after midnight and 8 hours after midnight. I guess the soonest it happens after midnight is at midnight, but if you're not okay with at midnight, then 8 hours later. You won't see one that comes up with such ambiguous answers where you have to decide between 0 and 8 on the homework, but this is a good example of why that k is important, because saying it happens 24 hours after midnight doesn't really make sense, because then we're on to the next day. So that happens at midnight. Got some leftover whiteboard marker. All right. A population of elk oscillates 150 above and below an average of 720 during the year, hitting the lowest value in January where t equals 0. We're going to find an equation for the population P in terms of the months since January, which we're going to represent with t. Well, they told us we're oscillating above and below this average, so that average is our midline. We're going 150 above and below, so that's our amplitude. Our period, so that's going to happen every year. So because we're using t to represent the number of months, our period is going to be 12. So period 12 equals 2 pi over b. Multiplying by b, dividing by 12, we get b equals 2 pi over 12, which is pi over 6. We know that the low happens when t equals 0, so this is just a regular, or sorry, not a regular, this is a negative cosine graph because we're starting at the absolute lowest. So our population in terms of t being the number of months since January is equal to negative our amplitude of 150 times the cosine of pi over 6 times our variable t, because we didn't have a horizontal shift, plus our midline, 720. In part B, if you will, it wants to know what if the lowest value of ELK occurred in March instead. That's just going to shift us horizontally to make sure our lowest lines up with that. Be careful. I had this wrong on my paper for the longest time. You want to shift it by 3 because March is the 3rd month. This is the number of years or number of months since January. February is 1 month later, March is 2 months later. So we just need to take this equation and make it shift to the right by 2. So if that were the case, we'd have P of t equals negative 150 times the cosine of pi over 6 times the quantity of t minus 2 plus 720. So just make sure you're reading very carefully because it's super easy to overlook something like that. All right, last one. We're going to work with a Ferris wheel again. A Ferris wheel is 45 meters in diameter and boarded from a platform that is 1 meter above the ground. The 6 o'clock position on the Ferris wheel is level with the loading platform. The wheel completes 1 full revolution in 10 minutes. How many minutes of the ride are spent higher than 27 meters above the ground? I'm going to draw a picture. So we have a Ferris wheel, and we know that it is 45 meters in diameter. And we have a platform that they load from, and that platform is 1 meter tall. So we can find the midline and the amplitude from this, because on the ride, the lowest they ever are is 1 meter. The highest they ever are is the 45 meters of the Ferris wheel plus the 1 meter where they load from. So the high is going to be 46. So that means our midline is at the average of those. 1 plus 46 over 2 is 23.5. We can find our amplitude by finding the distance from 46 to 23.5, or I guess the other way around, and that's 22.5. We know that our period is 10 minutes because that's how long it takes to go all the way around. Oops, 10. And if period equals 2 pi over b, then 10 equals 2 pi over b. Multiplying by b, dividing by 10, we get b equals 2 pi over 10, or pi over 5. Because they start at the bottom of the Ferris wheel, we're starting at our low point, which is negative cosine. So it looks like we have an equation we can write. The height, I'll call it h of t for time, is equal to negative 22.5 times the cosine of pi over 5 times t plus our amplitude of 23.5. Now we want to know when we are higher than 27 meters. So I'm going to set my height equal to 27 and see what that does. So we get 27 is equal to negative 22.5 times the cosine of pi over 5t plus 23.5. I'll subtract the 23.5 over, and we get 3.5 equals negative 22.5 times the cosine of pi over 5t. I'm going to divide both sides by negative 22.5, and we get 3.5 divided by negative 22.5 equals the cosine of pi over 5t. Oops, I missed my t. Now we can take the inverse cosine of both sides. I'm going to do this in radians because of the pi over 5. That just makes me think radians. My calculator is now in radians, so I'm going to take the inverse cosine. The inverse cosine of 3.5 divided by negative 22.5 is equal to 1.7270. So we took the inverse cosine, we still have the pi over 5t. So pi over 5t is equal to 1.7270. But that is only one solution. Because remember, we had a cosine that was negative. That happens in quadrant 2 and quadrant 3. So we also need our quadrant 3 answer. So let me pull out a piece of paper. The solution we have right now is 1.7270. If we think about our coordinates, we get 0, pi over 2, pi, 3 pi over 2. Pi over 2 up here is 1.57. So the value we got is slightly into quadrant 2. I still need my quadrant 3 answer though. To find my quadrant 3 answer, I need to find my reference angle. To find my reference angle, I take 2 pi minus what they gave me. Or sorry, pi minus what they gave me. So my reference angle is pi minus 1.7270, which is 1.4146. That's my reference angle. To find my entire third quadrant angle, then I need to take pi plus my reference angle. Pi plus my reference angle is equal to, okay, that is my reference angle, so I'm just going to add pi. And that's going to give me 4.5562. That is my other solution. Going back, that was equal to pi over 5t. So we had pi over 5t is equal to 1.7270. Hypothetically, we also have plus our 2 pi k. That won't be an issue this time, but it's good to practice with it. And pi over 5t is equal to 4.5562 plus 2 pi k. To solve for t, I divide both sides by pi over 5, which is the same as multiplying by 5 over pi. I'll just write it this way. I'm dividing by pi over 5. We get t equals 1.7270 divided by pi over 5 is equal to 2.7486. And then 2 pi divided by pi over 5 is just 10. And we still have the k out back. Working on the other one, we get t equals I need to divide by pi over 5. 4.5562 divided by pi over 5 is equal to 7.2514. And 2 pi k divided by pi over 5 is 10 k. So they first hit the height of however many meters, 27, at 2.7486 minutes. They then come back below it at 7.2514 minutes. So to figure out how long they were above it, we subtract them. So 7.2514 minus 2.7486 is equal to 4.5028 minutes. And that's what we got.